Hello viewers, welcome to Bhadra Academy. So once again we are here with a video of CUET undergraduate program in which we are going to discuss today about the series and parallel capacitance, right? So there are different combinations of capacitance connected in different combinations. Also here we have our phone number where you can answer your queries about the CUET undergraduate program, the course fees, the course structure and other details. So feel free to contact us. So let's begin with the topic, that is series and parallel capacitance. So very first we are going to see that the capacitors can be connected in different combinations. So the very first combination is series combination that we are going to see, in which the capacitors are connected one by one, right, one after another. So that is the series combination. So here you can see, and we can apply a potential here across the combination, right? So here the left side plates are charged of a positive, the right side plates are charged as negative. So here we can see also the capacitance is also denoted by C1 and C2, right? So here capacitors C1 and C2 are combined in series. The left plate C1 is charged by plus Q, and the right side C2 is charged by minus Q. So finally we can say that the potential drop across the combination, can be given by the sum of the potentials V1 and V2. So here potential drop V, you can see here in the equation V1 plus V2 is given, but again due to the from the capacitance formula we know that V is equal to Q by C. So V1 is equal to Q by C1 because the charge is same. Again V2 is equal to Q by C2 because the charge again here is same. Finally we can take out Q as common and we can put it down here below V, and now we will have this expression V by Q is equal to 1 by C1 plus 1 by C2, and finally V by Q we know that it is 1 by C, that is the capacitance. So finally the series combination equation we can get that the total capacitance is 1 by C and it is the sum of 1 by C1 plus 1 by C2. So this is the series combination, and if the number of capacitors are very high, that is the n number of capacitors, so finally the equation will become 1 by C is equal to 1 by C1, 1 by C2, 1 by C3 and 1 by Cn, n number of capacitors. So this is the formula of series combination. And now if we go for the parallel combination, right? So parallel combination, you can see the diagram again. The parallel combination, it is connected like this, where the potential is very common here. So therefore the potential is common, and again the left side plates are positively charged, right side plates are negatively charged. The capacitance C1 and C2 are denoted separately. So here is the combination, it is written here. And finally we can see that the total charge, now we will see the total charge that is given by Q1 plus Q2, where again from the capacitance formula we know that Q is equal to CV, that is C1 first capacitors charge 1 plus the potential is common, C2 and V, the V can be taken out common, Q by V again we know that it is capacitance C, and finally we have the equation for the parallel combination, that is capacitance, equivalent capacitance is equal to C1 plus C2. And if there are n number of capacitance, then it will be denoted by C is equal to C1, C2 and it is Cn. Okay, so these are the formulas for the series and parallel capacitance. I hope that this topic is clear to you. We will bring such videos, more videos. Till then, thank you so much.